This is the first video for section 9.5 series, and we're going to first start off talking about the summation notation. Summation notation is where you have the sum of the terms of a sequence. So what we were looking at in section 9.4, those were sequences, a list of numbers. In 9.5, they want you to add all of those numbers up that are in the sequence, and it's denoted by the sigma notation. It looks like a Greek letter E, and underneath it says k equals 1, meaning that's your starting number. And they call k the index of the summation. And the n that's up on top, they call that the upper limit of the summation. That's where it wants you to stop. And then the 1 where k is equal to 1, that's the lower limit of the summation. It's read as the sum of a sub k from k equals 1 to n. So for example, if I had the summation symbol, and I said, let's do here we go. If I said the sum of 2n minus 5 from n equals 1 to 10, that would mean that I would plug in 1 for the number n, I'd plug in 2 for the number n, I'd plug in 3 for the number n, and so on and so forth. And then you add up all of those terms, and there would be a total of 10 terms because you start at number 1 and you go up to number 10. Okay, let's look at writing a sum using summation notation. Here it says they want us to write each sum using summation notation, assuming that the suggested pattern will continue. So here you have to determine if it's going to be geometric or arithmetic. Now, if it was arithmetic, we know that there's a common difference, meaning that there has to be the same number in between the terms. So between 5 and negative 15, if you took negative 15 and you subtract 5, there's negative 20. Well, from 45, you subtract 15, that's 30. Okay, so the difference is not the same, so you know it's not arithmetic. So now let's test to see if it's geometric. Geometric would say I would have an R, and that would be by taking your let's say last term, which is negative 135, and dividing it by the previous term, which is 45. This comes out to be negative 3. Okay, well, let's try another one. That would say 45, divide that by the previous term, that's negative 15, and that comes out to be negative 3. And then you see if you did negative 15 over 5, that'll come out to be negative 3. So here our R is negative 3, and it is geometric. All right, well, we have to write our a sub n formula, and when you look at your a sub n formula, we know from section 9.4, you take a sub n is equal to your a sub 1, which is your first term, and our first term here is 5, times your r, and our r is negative 3, raised to the power of n minus 1. Now, if I want to write this in a summation notation, you have your sigma symbol here, and then we're going to look at, this has negative 3 to the n minus 1. If we want to write it, so let's say that k is equal to 0. Let's say that our first term, because when I plug in my first term, I'm going to end up with, if I plugged in 1, you'd have 1 minus 1 to give you a 0. And then you're just going to see the 5. So if we start at 0, then that's going to change our equation to be 5 times negative 3 to just the k value. So I'm saying k minus 1 in the, or n minus 1 in the explicit formula, but we're going to change that to be just k and then make it k equals 0 at the bottom. Now, where you look to where it's going to, like what's the last term that we're going to, because this has a dot, dot, dot up above, we're going to say that it's going to continue to infinity because it doesn't really give you an end or an infinite or a finite number where it's going to stop. So we're going to say it's carrying on infinitely. So we're going to just use the infinity sign. All right, so here was your sigma notation for the first one. I want you to go ahead and try the next one. I will tell you that on the next one, your index of the summation down at the bottom, your lower limit will be 1, not this original one where it's k equals 0. This was just one of those different types of cases. But if you look now at the bottom where it says try, go ahead and try and pause the video, and after you've done the work, come back and see if you've done that correctly. All right, this concludes the summation notation and writing a sum using summation notation.